Hi there. Welcome to Ranking Task Day 8. I apologize that it's coming to you in this format, but this is as good as I can do at the moment. So hang in there with me. All right. The first one, we have three students are discussing the magnitude and the resultant of the addition of two vectors A and B. Vector A has a magnitude of 5 centimeters and vector B has a magnitude of 3 centimeters. So we were just talking about in section 1.5 a vector. And a vector has two things: it has magnitude and it has direction. And the question is if I have two vectors, we have four students talking about when I have two vectors. Alexis says we'd have to know the directions of the vectors to know how big the resultant is going to be. Bert says since we are only asked about the magnitude of the resultant, we don't have to worry about the directions. The magnitude is just the size, so to find the magnitude of the resultant, we just have to add the sizes of the vectors. The magnitude of the resultant is, in this case, 8 centimeters. Okay? Kara said, no, these are vectors, and to find the magnitude, you have to use the Pythagorean theorem. In this case, the magnitude is the square root of 34, or a little less than 6 centimeters. And Dacia, the resultant is the vector that you have to add the first vector to get the second vector. In this case, the resultant is 2. So the question is, which one of these people are correct? And let me see if I can prove a couple of these people correct. So Kara says that these are vectors, and to find the magnitude, you have to use the Pythagorean theorem. So if I have a vector, we have two vectors, right? 5 and 3. If I have vector 5 right here, 5 centimeters, and a vector 3 right here, this would be my resultant. And the resultant, it'd be 5 squared, which is 25, plus 3 squared, which is 9, which is be the square root of 34 centimeters. So in this case, Kara is correct. But let's try to also take a look at Bert. What if my two vectors were in a straight line? So I went 5 centimeters east, and then I went 3 centimeters east. Then my resultant vector would be 5 plus 3, which is 8 centimeters. And for this reason, the correct person has to be Alexis, because we have to know more information about the direction. Because again, vectors do have both magnitude and direction. So we need that concept of direction to know exactly what is happening with those vectors. All right, what about the second one here? Let me hold on just a second here. Yes, it will. Let me. This is wonderful. Okay. Here we have four vectors, and they're labeled K, L, M, and N. And our question is, we know that J equals K plus L plus M plus N. So what does J look like? So if we're doing vector addition, we use what's called the head to tail method. And we'll be talking about this more later. But we literally take each vector and we place the tail of the second vector on the head of the first vector. So if I'm going to start with K is straight up. Let me just start right in the middle-ish. That should work. So K is straight up. Oh, it's 3 boxes though, not 2. All right, what about L? L is down and to the left. So here's K, here's L. What about M? M is down and to the right. There's M. All right, N is straight to the right, 2 squares. There's N. And the resultant vector, so think of these as all your distance vectors. Your displacement is where you started from to where you finished. And if I look at that, that's going to be D right there. So this is there's a few different ways that we're going to solve vectors, and one of the ways is called the graphical method. And that's what this is right here. It's the graphical method. We literally solve for the resultant vector graphically by doing all these head to tails. So we got resultant vector J by adding up all of our individual vectors. So that's it for today's ranking task. You still have to do 2 lessons for today, which is going to be 2.1 and 2.2. Have a great day.